we looked at sine yesterday, so we're going to look at cosine and tangent inverse today. And I'm just going to give you the other three. So this is still 6.5. I also realized I can do something so much easier for trying to draw the inverse graphs, which is I can just copy and paste my graph and rotate it. Okay, so for the cosine function, just to recall, it starts at 1 on our unit circle. X at 0 is 1, and then it goes to 0. So then at pi over 2, it's 0, and then at pi, it's -1.
Mr. Bennett.
Yeah.
I can only see you right now.
You can only see me better?
Yep.
Okay. So for cosine, we start at 1. On the unit circle, at 0 radians, it's 1, and then at pi over 2, it goes to 0, and then it goes to -1. That, and then down to 0 again, and then back to 1. To call these the 5 points, which is actually really effective. So at 0, it's 1, pi over 2, it's 0, and pi over 2. At pi, it's -1. At 3 pi over 2, it's 0, and then at 2 pi, it's 1 again. Since it's a periodic function, it will start to repeat, and then it'll look the same over here. Okay. Who can remind me of how we check a function is 1 to 1? So what test do we use for that?
Vertical line test.
Vertical line test.
Not the vertical, but
It's both.
The horizontal.
Horizontal and vertical.
Vertical checks if it's a function, horizontal checks if it's 1 to 1. I had mentioned yesterday, well, it's repetitive, so it's not going to be 1 to 1. If I were to draw a horizontal line, I go through points multiple times. So again, normally cosine, so this is cosine of x. Normally the domain is -infinity to infinity. But inverse functions, we can't have something occurring twice, otherwise it wouldn't be a function. Because what I would do, and this is where my Photoshop skills are going to come in handy. Essentially, this would become our graph of cosine inverse. But now it's failing the vertical line test, so it wouldn't actually be a function. So we have to restrict our domain, and if we look, we always want to start with a 0, because we want to include a 0. So I'm including 1 in my range right now, and if I go from 0 to pi, I'd be including all of the values in my range. My range is -1 to 1. So my new domain for, say, cosine inverse, to be able to have cosine inverse, I need my new domain to be 0 to pi. Otherwise, we'll fail the horizontal line test. So cosine inverse, if we remember, our inverses have opposite domain and range. So for cosine of inverse, the domain becomes it is the range. So the range was -1 to 1. So the domain is -1 to 1. And the range becomes our new domain. So it's going to be 0. No, not domain, range. So our range for the cosine inverse is 0 to pi. What quadrants does the range consider? So on my unit circle, what quadrants is 0 to pi?
Quadrant 1 and 2.
Quadrant 1 and 2. So this is something I like to do a lot for helping with problems. I always go, what quadrant is a given angle in? What quadrant does it actually need to be in? And if we look in quadrant 1, well, everything is positive. This is the all. And in this quadrant 2, only sine is positive, so cosine is negative. So we have our positive values in quadrant 1 and our negative values in quadrant 2. So every possible solution is covered by this, by the domain. Any questions so far with that? Okay. Again, if I were to go through, I'm going to do this right here. So for cosine of x, this is going to be our x. When we were doing cosine, our options, or our inputs really, actually, no, I did it on my table. I started at 0, I went to, I'm using pi's over 4, then I had pi over 2, then 3 pi over 4, then pi. So I had 1 root 2 over 2. So the pi's over 4 always have that root 2 over 2. Pi over 2 was 0. This is negative root 2 over 2, since it's negative for cosine. And then this was negative 1. For, in this case, I'd have x cosine inverse of x. I originally was taking in angles and giving out coordinates, but now I'm going to be taking in coordinates and giving angles. So negative 1, negative root 2 over 2, 0, root 2 over 2, and 1. And then I just copy what I had from before. So I'm just going to go, well, this is going to give me pi. This will be 3 pi over 4. This will be pi over 2. This will be pi over 4. And this is just 0. So this is essentially what we did exactly yesterday with sine, except instead of having quadrants 4 and 1, we have quadrants 1 and 2. So our identities are exactly the same, or almost exactly the same. So cosine inverse of cosine of x is equal to x as long as x is in the domain of cosine. So I'm actually going to write if, where's that? So the domain of cosine was 0 to pi. So 0 is less than or equal to x, less than or equal to pi. And then cosine of cosine inverse of x is equal to x as long as x is in the domain of inverse cosine. So if negative 1 is less than or equal to x, less than or equal to 1. This is also written as arc cosine, so if you see that in your text, they are the same thing, not ac cosine. So there is no difference between cosine inverse of x and arc cosine of x. They're the same thing in the book, you just treat them the same exact way. They're just different ways to write it. I don't actually know the history behind it, so that's something I might look up. Okay. So practicing some of our unit circle quickly. This is actually from yesterday. I had posted the unit circle. I can post that again really quick. We have that as reference right now. Looking at some samples, if I had cosine inverse of negative root 2 over 2, I'd want to find the angle that gives me this coordinate. So looking at the unit circle, what angle, it has to be in quadrant 1 or 2, gives you negative root 2 over 2.
Two over two. No, square root of 2 over 2.
Yep, what angle gives you this negative square root of
Angle?
2 over 2? Yeah.
135, I think that is.
So in terms of radians.
3 pi over 4 then.
3 pi over 4. Yep. I believe it is. So the 3 pi over 4 would be a 45-degree angle, so it would be 135 degree. Yeah, that would also be the same. So cosine inverse, normally when we did like cosine of something, so cosine we would have, say, 3 pi over 4. Normally if I had cosine 3 pi over 4, I'd find that angle and I'd get the x coordinate. This would give me the negative root 2 over 2. For the inverse functions, you're doing the opposite. So instead of getting the angle, you're going to go find that x coordinate and then tell me the angle. So then, same idea. What would be arc cosine of 0? So what angle produces this x coordinate?
Pi over 2.
Mm-hmm.
Pi over 2.
Yep. Alright, a few people aren't here, so this is just pi over 2. So cosine inverse of negative half. Okay, so right now we are going to be using one of our properties that's just above. So if we look, right now we have cosine inverse on the inside of the parentheses, so we're going to be using our second identity. So does negative a half fall between negative 1 and 1?
Yes.
Yeah. So our answer is just negative a half. And then looking at the other option, so if I have cosine inverse on the outside, I'm now using my property number 1. The question is, does 7 pi over 4 fall between 0 and pi?
No.
Yeah. Wait, for 1?
For property number 1.
Oh, wait. Does it? Should.
So if we think about this, if I had pi,
No, it doesn't.
it wouldn't.
Doesn't?
You're right. Because
Oh.
look, I could also write this as 4 pi over 4. The
Oh.
numerator is greater, so this is...
Yeah, okay. Yeah, I see that.
So if we look at our unit circle, what is the x-coordinate at 7 pi over 4?
Negative square root 3 over 2.
So I know
wait,
that
no,
I need
no,
to
that's wrong.
find, so this is negative root 3 over 2. So
No,
then
this
really the
isn't.
question is...
It's not. It's square root of 2 over 2.
Oh, yeah, no, it's square
My
root of
bad.
2 over 2. It's negative square root of 2
Yeah.
over 2. Yeah. It's a 4, so it should be root 2 over 2.
Yeah.
Okay. So I now know I need cosine inverse of negative root 2 over 2. What angle produces negative root 2 over 2 for cosine inverse? If I have to be in quadrant 1 or 2, what angle in quadrant 1 or 2 gives me x as negative root 2 over 2?
Quadrant 2.
It's going to be in quadrant 2, yep, because it's a negative.
3 pi over 4?
3 pi over 4. Good. So this kind of ties into the idea of reference angles, but then also that we had done it in class when we were first constructing the unit circle. We kind of did the matching of lines. So I had, this would be 7 pi over 4. We had drawn just, using a straight edge, we found a reference. So if it doesn't fall within your domain, you have to make sure it's in the right quadrant. Okay, so that wraps that up for cosine. We're just going to move on to tan. We're not really going to do too many examples with tan, and then I'm just going to give you a chart for the remaining 3. I'm going to zoom out. Any questions with the inverse cosine?
No.
Okay. So this is the inverse tan or the arctan. We never actually got to really graph the tan function. I'm going to pull up my calculator super quick. I'm going to... I also just realized I never shared my calculator screen yesterday, so when I was saying, look, they mirror, people were probably thinking I'm insane. Can people see my calculator right now?
Yep.
Yeah.
Okay. If I go to y equals, I'm going to change these. I'm going to go plug in tangent of x. If we recall with tangent, when we were defining tangent, there are angles that it cannot equal. Reason being, you'd get a divide by 0. I'm also going to go graph just y equals 1. So again, we would check, well, does this pass a horizontal line test to see if it's 1 to 1? Clearly it doesn't, it fails. So we'd have to find our domain. If we were to do this out, we would find, or even if we had the rules on us, we know that tangent isn't defined at pi over 2, 3 pi over 2, 5 pi over 2. So an odd numerator coefficient over 2. So kind of cheating. I'm just going to inform us that our domain restricted is going to be, can we see the whiteboard again?
Yeah.
Yep.
Yes.
So our new domain is negative pi over 2 to pi over 2. I'm going to graph this super quick. At those values, we would have asymptotes. So tangent, we start dividing by smaller and smaller x's. So it grows to infinity. At pi over 4, it's 1. The nice thing about tangent is that pi over 4, it's 1. The reason being is that this is equal to y over x, where y is root 2 over 2, and x is also root 2 over 2. So here's my 1, here's my negative 1. I'm going to go, oh yeah, it's this way. It's kind of like quadratic in that it looks parabolic, but it's not quite. So this would be our graph for the tangent function. And then what I can nicely do, actually, if I wanted to see the graph of the inverse tangent function, and this way I don't have to change anything right now. First, our range. The range can be any value from negative infinity to infinity. So for tan inverse, what is the domain of tan inverse? That should not be a hard race. if the range of tangent is negative infinity to infinity, what's the domain of tangent inverse?
Wouldn't the domain be the same thing?
Yep, it's just going to become the range. It's going to be that negative infinity to infinity. It just switches, so the inverse just switches the domain and the range. And then my range just becomes the negative. Actually, this needs to be a. This needs to be a open parenthesis since it doesn't actually include the point. So, but I think that's what I was starting to say. It is negative 2 pi over 2 to pi over 2. And then yesterday we had discussed the fact that I should actually fix something real quick. After this, I'm going to go fix a graph. We had discussed the fact that this mirrors about y equals x, which means I didn't actually mirror my other one, I rotated it. So my graph for tangent inverse, I'm going to bring this over here. I need to transform this. I need to flip it about the vertical, I think. Yep. Oh, I did the wrong thing. I did an image instead of the layer. Oh, there we go. Transform selection. Rotate it, and then I'm going to mirror it. Okay. So I have now rotated and mirrored my my graph. So this, if I then go rewrite things not the wrong way, so this becomes our graph for tangent inverse. I just took it and I mirrored it, so it looks a lot like the tangent function, just rotated a little bit, which it should. If you want to get the table, you can get the table on a calculator. We're not going to worry about it too much. But again, the idea is that whenever we do these, you're just taking mirrors and rotations of a graph, and your domain and range are just switching. So I'm going to go ahead now, and the last thing we're going to check are the other functions. I can repeat the idea from before, so tangent inverse tangent of x is equal to x if x is between negative pi over 2 and pi over 2. For this one, we can't actually include the negative pi over 2 and pi over 2, so that's why it's just less than and not less than or equal to signs. And then tan of tan inverse is always equal to x. So because the domain of tan inverse is negative infinity to infinity, this is always true. So there's no restriction for if you have tan inverse on the inside bracket. And then to almost end the video, so we have our last three functions as cotangent. We have x equals secant inverse of x, and x equals cosecant inverse of x. And then we have our domain and our range. So for cotangent, this is again going to be negative infinity to infinity. And for here, cosine goes with 0 to pi, so since our x value is in the numerator and our y is in the denominator, our range is going to be 0 to pi. For secant and cosecant, these ones are a little bit odd. We can get these from the rules in the past, but it's going to be from negative infinity to negative 1 with the union of 1 to infinity. It's going to be the same for the domain for cosecant. This is negative infinity to negative 1 and the union of 1 to infinity. And then our ranges are 0 to pi over 2 and the union of pi over 2 to pi. So it's everything from 0 to pi except for pi over 2, because at pi over 2 cosine would be 0, so you divide by 0 error. And then for here, it's going to be negative pi over 2 to 0, the union of 0 to pi over 2. That's it for the material for this one. If you want as practice, there are a few problems you can look at. There's nothing really different from what they were before. It's just, again, finding, not root 2. It's just using the unit circle to find the values. So it's the same exact process as we did for sine and cosine, just say with tangent or cosecant. So I'm going to leave 2 practice problems, and then I'm going to fix one small mistake I have. Tan of tan inverse of 17. I forgot earlier to mirror this graph. So the actual graph for cosine inverse, I'm going to use this table to make it. So at negative 1, I'm at pi. So I'm going to say this is negative 1 pi. It's good enough. At negative root 2, I'm at 3 pi over 4. Then at 0, I'm at pi over 2. At root 2 over 2, I'm at pi over 4. And then at 1, I'm at 0. So this would be the graph for cosine of inverse. I forgot to mirror this guy, which is why it may not look the same, so I'm going to mirror this really quick if I can. I'm in the wrong way. Are there any questions while I fix this?
No, not really.
Not really?
No.
Any questions from anyone? Is that the wrong layer? That's also the wrong layer. Okay. If not, that's it for today. Tomorrow it's going to be the same time. We're going to be finishing up.
Can you just go back to the last table you made?
Yeah. I'm going to zoom out a little bit. Let me zoom back in. So tomorrow we're going to look, instead of using nice values for our unit circle, so we're not going to be doing like the root 2's over 2, the root 3's over 2's, or the halves. We're going to be doing exact values, which just involves us drawing more right triangles. So that's a taste of what's going to be up tomorrow.